Today we look at linear graph not passing through the origin. Most of the time, students will be asked to find the intercept of a graph on the y-axis. So we want to look at it. Here we have the values of distance, meters, and time in seconds. And the values are plotted here using a scale of 2 cm to 2 meters on the y-axis and 2 cm to 1 second on the x-axis. So the values are plotted, and these are the values. 4 meters correspond to 1 second, 6 meters correspond to 2 seconds, 8 meters correspond to 3 seconds, 10 meters correspond to this, and so on. So after plotting these values, we have the best line of fit, and this time the graph is not starting from the origin. We have the intercept where the best line of fit meets the y-axis. We read it, and at this point we say that y is equal to 2 and x is equal to 0. X is equal to 0, y is equal to 2. So when you look at this linear graph not passing through the origin, the equation takes the form y equal to mx plus c, where x is the independent variable and y is the dependent variable. M is the gradient or slope, and c is the intercept. So at this point, our intercept c is equal to 0. Sorry, intercept c is equal to 2. That is where y takes the value of 2 and x equal to 0. So if you plug this in this equation, y equal to mx plus c, at this point we have y is equal to m0 because the value of x is 0 plus 2. The intercept is 2. So we can say that y is equal to 2. So you can see that when the value of x is 0, the value of y will be equal to 2 and will be the same thing as the intercept. So what happens if x is equal to 1? What will be the value? If x is equal to 1, then y will be equal to m plus c. M plus c. And in this case, our c, where c is equal to 2, y now will be equal to m plus 2. And m, as we know, is the gradient. So if you are asked to find the intercept, that is what you do. The point where your best line of fit intercepts the y-axis. So this is how we read it and how you take your readings on the graph.